Hello and welcome to this session. From here on, we'll start creating a project and we'll start creating the required tables for Amazon database. Right, we were in our previous session discussing about the data that Amazon stores, right? So the product information, who bought, how much they bought, so that they can answer certain questions like, hey, how much revenue we have generated in the last few days, in the last 1 month, or which location is giving us a loss, great sales, and which location is giving the least sales, so that the leadership team can take decisions based on the data. So the first thing is we need to store this data, right? So here I'm in the SQL developer. So I talked about the databases, right? So we have the root database. Within the root database, we have the pluggable database, right? Database, we can have as many databases as we want, right? So here we had CD root, that was a root database. Then we had the pluggable database as well, to which we have connected. So I'm connected to these underscore dev. So what is the database name? So if you want to see the database name, so you can see this one, show con name. So this is basically the database name. All right. So now within the database, right? So I talked about the database at a very high level. Within the database, you will have schema. Schema basically organizes the data in a structured way. All right. So schema is basically a user. All right. So like for example, if you just expand this, click on this plus symbol, you can see like tables are here, views, all this are like structurally arranged and they all are under this schema, right? So we have database first. Uh, Under the database, we have schema. Under the schema, then we have tables and other objects. Okay, so this is basically the hierarchy here. Okay, so see, in laptop or in your system, right? So you have a folder, the main folder, which is your database. Under this, you have subfolders where you want to organize data, right? So all our data, all our information that we are going to do, so we will store in one schema. And then what we will do is we would basically you create the tables under this. So for all our Amazon related data, let's store this into the schema called DESA, right? So that is a schema because that is a user. If you want to check that schema, so you can do select user from dual. So this will basically give you the current schema that you are in. Okay? So you see this. So our database name is this one. Our schema is this one. So in typically what happens in project is the database administrator will create multiple databases. They'll create multiple schemas. So they will basically provide access to those schemas. Okay. So but we are in local system. So we are creating users. So the user is the same schema. Now I have that user. So there are schemas, there are users which are commonly used by all the engineers. Like in a team, you will have your own user, but then you will also have a group user where a particular user, like for example, Amazon user, right? So that user will be created and everybody will have access to that user. Okay. So again, it will go through a lot of process. Different companies will have different process, like they log in through SSO and all those things. You don't have to worry about all of this. But right now here we have a database, this XCPDB1. Then we have a user, this, right? So we're going to create the date tables using these two, this schema and this database. Now, again, just to recap, what we're going to create is like we want to store all this information that you are seeing in our database, so that in our table, so that we can retrieve such information and we can write queries and answer questions which a leadership team wants to know. Okay, so what are the information that we can store here? See, if you look at it, you're looking at the products, right? So you can store the information of products like, hey, this product, what is the name of this product, how much does it cost, right? So it's basic details. Like then if you want to talk about users, right, somebody has to buy that, right? So you can maintain details like user, what is the username, the location, simple things, right? Then once you have a user buys it, then it goes for a delivery, right? So you can have the delivery details, whether it's shipped, whether it's in transit, or whether it's delivered. Then user will purchase it, and then user may not like it, so it might go for refund, return, right? So whether the product is returned safely, whether the refund has been issued, all this information they will store it in their tables. Okay, so we'll also try to replicate most of this in our tables. So now first thing we need to do is we need to create tables to actually store. Now the question is, should we create one single tables to store all this information, or should we create multiple tables, right? Like user information will store it in user, product information will store it in product. Okay, so there are two ways, right? So the right way to do is to actually store different tables, different categorization of data into different tables. Okay. Now, I can have a theory class to explain why that is done, but let's try to do the wrong thing first and see like what is happening there. So if you do something wrong, and then you will analyze like why this is wrong and what are the things that we can improve on it, that is something that will stick to your brain for a longer period. So we will do this thing. So what we'll do is we'll do a bad design. Bad design basically having all the data into a single table. And then we'll analyze and see like what are the issues that we are facing if we have all the data into the single table, and then we will correct that, and when we will go back and see like, oh, these are the issues that we have when we have the data in a single table, and then we will ensure that we will correct that, and going forward we will use data in the right way. And as we learn more and more concepts, we will start implementing those concepts here. So slow, step by step we'll go. Okay. All right, so the first step that we need to do is we need to create a table. So I'm going to create a table here. So I'll say create table, database name dot username. So this is Lisa table. So let's say Amazon all data. This is my table. Okay, so let me pull this down a bit. Let's start, right? So I'll put a comment here. Double slash is a comment. So I'll say let's start with the user details. So I will have user ID. So user ID basically is the ID given to a user. So instead of name, so you'll give a user ID. We'll store some ID here. So this will be number two. Let's say number three, so that okay, we might have a lot of users, right? If you want to create like 1,000 users or 10,000 users, then this is not a good user ID. So two. So let's give 10 for the time being. Username. What is the username? So this would be varchar two. Let's give it 100. Uh, user. We also want to store the user email. Okay. Again, varchar2, this should be 50 or maybe 100. Okay. To be on the safer side. User city, let's give varchar2, let's do it 50. Then user country. Okay, another varchar2 of 50. Okay, so we have all the user details. I think this should be sufficient for the users. Then let's go with order. Okay, what is the order ID? Okay, order ID could be a lot of numbers, so let's just give number 10. When is the order made, right? So we'll give a date, order date. What is the order status? Okay, so we go and check the order status right in Amazon. So let's put it as 50. Okay, I think this should be sufficient for now. What else? Product. Okay, we talked about product. Okay, again, I'll say product ID. This is number. Again, I'll put number 10. Okay, we are creating product ID. Our product will have its name, right? What we have is target 2, let's say 100. Then product price. Okay, product price. Let's put number, and we give a precision. Okay, 10 comma 2, which basically means before dot you can have 8 digits, after dot you can have 2 digits. Okay, that's a maximum, right? Hmm. What else? Category. Okay, let's say category name. So category name will tell you like what categories. Like, is it electronics category? Is it like vegetables? So I think they don't do vegetables, but anyway, they have Amazon Fresh for vegetables. So I'm technically not wrong, but it's okay. Okay, so categories. I then order item. Let's say order item. Uh, this can be put here, I guess. Yeah, you can put this here, quantity, right? So let's put one thing here, quantity number of 5. Okay. Mm. Okay, we can remove this. We can put quantity. What else we can have? Okay, payment, right? So important payment. So how is the payment done? Or let's say payment ID. Okay, again, 10. When is the payment done? That would be date. What is the amount that is being paid? Let's say 10 comma 2 less payment status, whether the payment is successful or it failed, those kind of stuff. Then what we'll do is shipment, right? So where is it shipped? Shipment ID, let's say shipment ID. So I'm randomly just adding some data here. Okay. So I'm randomly putting some columns here because anyway, this is not something that we're going to use, but we wanted to just learn something, right? So uh, ship date, this will be date. Then what? Okay. We also have a delivery date. And mm, okay, let's put review as well, right? Rating. So rating would be 1 star, 2 star, 3 star. So that would be okay. 2 should be good. Um, Review date. When was this review done? Then in information, seller information. So seller ID. Let's say number 10. Uh, Seller name. Circle 2 of 100. Quantity that we have. I think this is not required. Okay, let's keep this one out. Then what else? Refund, right? Return and refund. Let's put return and refund. Mm, Return ID. So we want to track the return ID. When is this returned? So date, right? Reason. Let's put back at 2 of 200. So refund ID, number of 10. Uh, okay, remount, right? If there are any cut, right? So service charges or anything, which I don't think there is service charge, but we'll just put it. Okay, so I think this is good. We have quite a few columns here, like we have the user information, we have the order information, the product. Let's put this aside. We have the payment related information. Uh, we have the shipment details, the reviews, seller information, return, refund. All this information is here. So let's go ahead and create this table. Yes, I think this got created. Mm, Missing or invalid action. Okay, so good. We have our error here. So some way because I didn't copy it from anywhere, so maybe I missed something somewhere. So I'll have to debug what happened here. So let's give me a minute. This is good that we have an error here. So missing or invalid option is specified. Missing or invalid option. Um, An invalid option was specified in defining a column or storage class. The valid option, a column was not null to specify that the column cannot contain any element. Only constant may follow the data type. Specifying the maximum length on a date or long also causes this error. Did we specify anything on the date? That's interesting. Okay. Let me check this. Eh, everything looks good here. Okay, you can see there is syntax error, right? Okay. Okay, so this is the database which is provided from here, right? So we need to remove this. So typically, like in Oracle, like if you look at Snowflake and everything, you can use database name dot schema name dot user. But since we have not created the database here, we are using the database that is actually provided uh, by the by the Oracle. Like we are using the pluggable database which is provided by the Oracle. So we'll not be able to use that in the dot. So instead of database name dot schema name dot uh, the the table name, we will use schema name dot username, right? So because I actually thought of like we'll create a database first and then we will create schemas and all, but we are using the database which is a pluggable database which is provided by the Oracle. So I actually wanted to kind of use the 11G version where we could create a database, but unfortunately, what happened is the 11G database was a little bit unstable when I tried, so I went with the latest version. So they usually stop supporting some of the functionalities there. That is the reason why I use the latest version. So please ignore what I've said earlier, where like you have to use database name dot schema. That was when my initial thing was like to get into the 11G. But anyways, uh, I'm not going to edit that as well. Like I'll just keep that so that you will understand like the difference between the different versions. So we are using the schema here. So uh, if you are an Oracle SQL, so you can ignore this. You can kind of like create this. You can use a create table only. You don't have to mention the schema. So we'll also not mention the schema going forward because we are basically using just one schema, right? So we're not creating a new schema, right? We'll create another user, but that is fine. So instead of using this, we can basically use just a create table. Now I'm going to create this. The table is created. So let's look at the description first. Is on all data. Okay. Let's look at this description. Okay. So we have all this. Right now we don't have any data in this. So Amazon data is not here. So let's execute this. There is no data. Now we need to kind of insert some data into this. Okay. All right, so I'm going to prepare an insert statement here, and I'm going to copy this insert statement here. So I'll pause this video for now, so I'll go back and create this insert statement because that will take some time. Just to keep the video a little bit shorter, I'll create an insert statement and I'll paste it and I'll paste this in the article session for you to go through it. All right. All right, so I have created the insert statement. So I'm going to copy this insert statement into the article session so you can go through it. So look at this insert into the Amazon all data values, and I'm giving the values here, the ID, name, email, location, country, and all those things. All right. So date basically is the current date. So you can basically copy this and execute this. Don't worry about whatever the values that we have put here. Just execute all of this. I'm just gonna select all of this and I will execute this as a script. So it will insert all of this. Okay. So I think all the records got inserted. So now I go back and select the data. So let's do a select start. Okay, so now you can see that the data is all here. All right. So we have the data, very good data, right, with all proper details, correct? It has a written reason, what is the return date, refund ID, refund amount, all this information. A lot of these are null because not every item gets returned, right? So a lot of information is there here. So now let's closely look at this data and try to identify why this is a bad design, right? So we talked about this, like this is a very bad design, right? Why you want to use the same table again and again. Okay, so for that, before that, let me just order it. Okay, so now you can see, right, user ID 101, 101. There is another 101 here. There is another 101 here. Okay, so I'm going to sort this. So I will say order by user ID. We'll talk about order ID again at the later sessions, but basically order ID is used to sort this data. Okay, you can sort it in ascending, you can sort it in descending. So by default, it is ascending. So if you don't specify anything, it is ascending. So let me just execute it. So now you can see that all this data is here. Okay, all this data is sorted. Now let's understand. Okay, what is the problems here? Okay, now if you look at this, right? So the user ID one, not one, right? So you have user ID one, username, email, city, country, right? And till here, whatever I've highlighted, right? So these are the four records that are repeated. This is the data redundancy, right? Why we need to repeat all this information again and again? Because user ID, username, everything is remaining same, but we are still storing it because this person has like four orders. So for every order, like every time the user is ordering something, we are basically storing his user ID, username, email, and everything again. So this is a data redundancy. It's basically user ID is duplicated, and therefore there is a lot of wastage that happens, right? The other problem with this is like suppose user has changed the email, right? Now what happens is, right, if I want to do an update, so I will say I use an update statement to update this user email. So I need to update it at all places where the user has changed, where the user is one not one, right? So that again, a lot of updates that goes in, correct? So multiple updates, it will degrade the performance. So I will have to basically say it update this table, set user email is equal to something, let's say sam@gmail.com, where user ID is equal to 101. Now it has 5 records, it will update all those 5. If it has 10 records, it will update all the 10 records, right? So it is really, really bad, right? Because it wastes time, updates are slow, right? Okay, now this is on the user. So let's scroll a little bit here as well. Similar to this, right? So we have what we call products, okay? Now, if you want to add a new product, correct? So if you want to add a new product, where will you add that? Unless the user buys it, because it's all interlinked, right? So if the user, nobody has purchased that product, you will not know whether that product is there or not. So here, as per the design, what we have is like user is buying something. So whatever is related to the user, you are actually adding it. But what about the products? If you want to look at the inventory, what happens? You will not know, right? Because that information will not be there. So that is where the problem can happen. And the other is like the delete. Like, for example, if you're deleting something, let's say if you want to delete some ID, right? So there might be something which is related to the ID. Like, for example, if you want to delete an uh, if you want to delete an order ID, that order ID is associated with some inventory. Like, say somebody has purchased an order, somebody purchased a TV, and that is the first time, and you're deleting it, and then what happens along with that, the product information is also get deleted. So, and again, there is an issue, right? So every time, these things are like clubbed together. So a lot of issues happens, right? Now there are also like a lot of fields which are like, columns which are irrelevant. Like for example, let's say here in this column written, right? All these are null. Most of the fields are null, right? Because if the order is not written, then why we store that information? There is no point in knowing, right? Only if the order is written, item is written, then only we'll go and check like what is the issue with that order item. When is it written? What is the reason for that written? And how much we have refunded? And what is the ID? All these things will happen only if the order is written. But here we are basically having every information here. Doesn't matter like whether the order is written or not, right? So lot of information is there, right? And here also the other thing with this table is like I can add any data here, right? For example, instead of username, I can add a product name and still it will accept. So there are like the constraints are there. There is no validation. There is, you can add anything that you want, any garbage data that you want, and it will still accept it. So this is the problem with this design. If you put everything into a single table, this is a problem. So now what happens is, again, before that, let me just recap whatever we have discussed, right? So one is like duplicate data. Yes, there is a lot of duplicate data. Even if we don't require this data, there is a lot of duplicates. Because there is a lot of duplicates, you have to if you want to update something, you will have to update so much of data. This will slow down. Similarly, if you want to insert something and let's say a product, but if if we don't have any relevant information or user for this, we'll not be able to insert, right? It does not, you can still insert it, but then it will not match anything, right? Similarly, deletes are a big headache, right? Then you have a lot of data there where we are we don't require the data, but we are still storing it because it's all part of the table, right? So again, anybody can put any data, any garbage data, it will accept it. There is no validation. So this is why, such table, if you maintain, and also when you maintain this table, right, as a storage increase, it becomes very difficult for maintenance as well, right? So that is the reason why we normalize it. Normalize is basically breaking those bigger tables into smaller tables so that we can control it. So now in the next session, what we will see is we will basically normalize this table, and instead of one big table, what we are going to do is we're going to develop smaller tables, and we're going to insert these smaller tables and see like how some of these things that we have seen, we are trying to solve some of the problems, right? The first problem that you've seen is like a bigger table, right? So too much of data is getting wasted, right? Now the next step is to kind of normalize these bigger tables. Then we'll add a smaller tables. After that, we will identify what are the issues that we face in those smaller tables. And then what we will do is we'll keep on adding more validations. We'll keep on adding more rules for this table so that we reduce some of the issues that we face. So we'll go step by step. All right. So now that we understood the problem with this table, so what I'm going to do is like we no longer need this table, or if you want to keep it for any future reference, we can keep it. So it's so fine. All right. So this is what I want to talk about in this session. I hope this was clear, and I'll see you guys in my next class.